This is a demo on how to create and extend logical volumes. So the first step we want to do is log into the root user. And this is because most of the commands that we're going to be using require root permissions. Second thing we want to do is run apt install LVM2, because that's the software that we're going to be using to actually manage our logical volumes. We'll enter, no upgrades, please. Enter yes, and we'll let that install. And the next thing we want to do after this is done is run lsblk to find out the device names. Now, if you can look in the bottom right corner here, you can see I've added 4 extra hard drives. So we have a 20 gigabyte one that has our operating system, and there's 4 extra ones. We're going to be using 3 of them at first for our first logical volume. Let's actually run lsblk and I'll show you. So we're going to be using B, C, and D here for our logical volume at first, and then we're going to extend it by using SDE here. So we'll run pv-create to create physical volumes, and we're going to specify the device names we want. So that's going to be SDB, SDC, and SDD. And we have our physical volumes. The next step is to create a volume group. So we're going to use VG create, which is volume group create. We'll specify a name, which is going to be volume group pool or VG pool. And then we specify the devices that we want to add, the physical volumes that we want to add. And that's SDB, SDC, and SDD. And we have our volume group. So let's use VG display to find out some information about our volume group. We have our name of the volume group here, which we already knew. We have the access and the status, so it's read and write, and it's resizable, which will come in handy later. We have our size here, which is 17.99 gigabytes, which doesn't seem like a very easy number to type in when we're specifying the size of our logical volume. So we're going to use a different way of typing in the space that we want to get around that. So we will do lv-create to create a logical volume. We will specify a size with -L. We're going to say 100% free, which means that it's going to use 100% of the free space on the volume group that we specify. We'll use -N to specify a name for our logical volume. We'll call it LV files because we're going to make a folder called files, and we're going to mount it to that directory. Then we're going to specify the volume group that we want this logical volume to be a part of. And we'll hit enter. We now have our logical volume. So let's use LV display to actually see our logical volume, because we're going to need this path right here for our next command, which is creating a file system on it. Because as of right now, this isn't actually going to be usable. It's not mounted for one, and it also does not have a usable file system on it. We can also see that the size is exactly 17.99 gigabytes. It did, in fact, use 100% of the free space on our volume group. So let's go ahead and run mkfs -t ext4. So we're creating the file system ext4, and we're going to create that on dev/vgpool/mdfiles. Run that. So we now have a file system there. We're going to copy this UUID for later on, because we need this when we're going to be mounting our file system by editing the fstab file. And before we mount, we're going to actually create the mount point. So we'll make a directory, make directory files. As you can see, we have a folder called files now in our root folder, and that's going to be the mount point. So we'll open the fstab file in nano, and we'll mount it like we did last week with the partitions that we were making. Paste the UUID. The mount point is going to be /files. The type is going to be ext4. The options are going to be defaults. The dump will be 0, and the pass will be 2. And we will write this out and then exit. Let's mount it by running mount -a. We have no errors, so that should be successful. Let's just check df-h to see. And there it is. We have our vgpool-ld files mounted to our /files folder, and it's approximately 18 gigabytes in size because it's made up of 3 6 gigabyte drives. We're gonna add files to our logical volume at the mount point just to see how df-h changes. So let's change our directory. We will use the fallocate command -l to specify size, 500 megabytes, and we'll call the file test. Let's see that it's there. Yep, we have our 500 megabyte test file. Let's run df-h, and as you can see, our use percentage went up a little bit, and the used space on our logical volume also went up a little bit. So this is working as intended. We have successfully created and mounted our logical volume, and it's usable. The next thing that we're going to do is extend the logical volume. In order to do this, we need to create a physical volume using that 4th drive, SDE, and then we're going to run VG extend and LV extend to extend the volume group and the logical volume. So first things first, let's run lsblk again just to check the device names. So you can see the command is, the output has changed a little bit from the first time because now it's showing us that our physical volumes are part of VG-pool, and the logical volume they're part of as well. But this SDE is still unused, so we're gonna go ahead and pd create /dev/SDE. Then we're going to volume group extend VG-pool with dev/SDE, our new physical volume. Then we are going to LV extend, specify size with -l. We're going to say +100% free. We're using the same little technique we did before to make sure that we're using up all of the free space that we have and not truncating the amount of gigabytes and losing that 0.99 by specifying just a gigabyte number. We'll use -r as well, which is an option that allows us to resize the file system with this command. So instead of running the command to resize 2fs separately, this will actually run it for us on our volume group, and on our logical volume, to make sure that the file system is extended to take up the new space that we've added. So let's specify that it's the VG-pool/LV files, and let's run it. So there we go. We've successfully changed the size of our logical volume from 17.99 gigabytes to 2.398. So we're losing a little bit of space to headers, as you can see by this funny number. And here's the resize 2fs command that I was talking about. So this is actually telling us that the file system that we're trying to resize is mounted somewhere, and it's going to mount it online. So our file system is still mounted, but we've actually managed to resize it. So let's run df-h just to check that that's actually correct, and everything is here. We have our full size, the 24 gigabytes, which is rounded from this number. The available number, which is rounded down from 22 point something probably. We have a used number that hasn't changed because we still have that 500 megabyte file, and we're still mounted on /files. So that was a demo on how to create and extend your logical volumes.